Okay, I see everything is up and running again. Okay, sorry about that. Just had a quick power outage this side. Let's get back. Okay. So first things first on the parallel session for today, we're going to start with the basics, and that's on the monitoring page to make sure that your setup is done correctly on the page, and then that your firmware is also on the same versions. That's fairly important. If your firmware isn't on the same versions, you won't be able to parallel your machines. They won't function right, and they'll give you an error 08 for CAN communication failure in parallel system. So first things first, on this page, you'll start by configuration. That's when you install the two systems. Then you just go and add a station. And then once you've added the station, you add both dongles under the same station. So once you've added both dongles under the same station, as you see here, both dongles is added under the same station. So you can see both inverters. Then you parallel them. So let's quickly go to configuration. Let's quickly search for the station again. Then you see your station. Okay, now you've added both dongles under the same station, as you see here. Then you'll see on the right-hand side, there's a parallel box. You click the parallel box and you enter 1 for the first inverter, and the second inverter is going to be 2. As soon as you've done this, you're telling the server that this 2 inverters is in parallel, and he must combine this 2 dongles information for you. So once you've done that, you can go back to your monitor page. Then you'll see your inverters will show a box with 1, 2, 3, 4, 5, 6 inverters in it. And that box that you see there means that your system is in parallel on the monitoring page. It doesn't mean it's in parallel on the machines itself. It only means it is mixing the 2 inverters information into one and giving you one complete information sheet about the 2 inverters. At the bottom is where you can see each inverter's individual report what's happening. So you can see your PV voltage of the first MPPT, the second MPPT, the SOC of the batteries, your battery voltage, which inverter is charging how much, and the total discharge when it's in backup mode, what's the total that you'll be discharging at that moment there. Now, from here on is a very important step. Go to maintain. Once you've reached maintain page, you'll see at the side, you have all these options. Now, these options will only be available when you have an installer's account. Very important. If you don't have an installer's account and you're installing Luxpower, please contact us so that we can provide you with the right account so that you can also be able to update machines at will and don't have to wait for one of the Luxpower support members to help you to update. You'll be able to update it yourself, so you don't have to wait. So from here on, you go to remote update. So you click the remote update button. Then you'll see here at the left is a station box. You click the station box. Then you'll see the 2 inverters in the same station. That's here. Now for this system, it's very important to have a look at the firmware code. This code here has to be the same before a parallel system will function correctly. And it is advised to update your inverters to the newest software when you install the parallel system, because the newer firmware has a lot of fixes for small bugs that was in the firmware on the older versions. So it's always advisable to upgrade your firmware to the same version. So that's basically for the monitoring page, what you have to do to get your units together. To do the update, you just press on the standard update, and then you'll see on the side, it starts to update. There's 3 updates that will be done on this system. Okay, so that's basically how you do the standard update, and you press it on the side there for the second inverter, and both of them will run through. You can also check if all three updates were successful by going to the update record button here. You press on your update record button, and then you'll see only your information will display here. Mine will just show all the installers' accounts, but here you'll see, let's take this one for example. You'll see from this guy, there was 3 updates. There's the first update that was done. Then there's the second update has failed. They just had reinitiated the update. It will take off where it left off. Then there was a second update, and there was the third update done on this inverter. So you can see it's a 1, 2, 3 successfuls. Then your inverter has been fully updated. There's 3 updates that has to be done. That's that for the monitoring page. Is there any questions that you guys would like to ask before we move to the physical settings and wiring work of the parallel system on this monitoring page?
Hello.
Hello.
Yeah, I want to ask one question. What internet speed, minimum internet speed will require to monitor all of these things?
Okay, that's a difficult question. If you at least have a 1 to 2 meg line, it should be fine. But the most important part of the internet connection is the stability. It doesn't help you have a very fast line, but it's unstable. That's what we are having a problem with on monitoring side is if you have an internet connection that is fast but very unstable, it keeps on disconnecting from the server and then disconnecting. So it's better to have a slower internet connection, but your stability of the connection is what is really important in this matter. We don't need a fast internet connection. We only need a stable internet connection. So if you have a 1 to 2 meg line that's stable, it will perfectly work without any trouble.
Okay. If in case if internet connection is not stable, okay, so what happened in that case? The data will be logged in local machine, or it may impact on server data also?
Yes. In this case, as soon as your inverter is disconnected from the internet, it will go to its local backup on the inverter itself. So meaning as soon as the inverter reconnects to the internet again, then that history that it recorded will be uploaded again for you to view. So it has, I think, up to 90 days, if I'm not mistaken, that it can do a local backup on the machine itself, so that if your internet connection comes back, then you still have that history of that time that your machine wasn't connected to the internet.
Okay, thank you.
100%. Any other questions that somebody might have? Okay, I don't see any other questions that's coming up. So I believe everybody understands the part of the firmware to check if it's the same and how to get your monitor to display the 2 inverters as a parallel system. So I believe all is fine there. If there's any questions, please ask the questions. I'll stop every now and then and check the chat box to see if there's any questions. Feel free to stop me at any given time. I'm going to move on to the physical settings on the screen for parallel system. So if everybody can pin the one that says Yahoo screen, just give me a thumbs up if everybody can see that screen. You will see it's a inverter screen for the SN5000 that's on Yahoo screen. I'm going to use that one to explain some of the settings of the inverter. I'm going to give everybody a few seconds just to move through that screen. So I'm going to stop this one. Okay. I believe everybody can see the one that says Yahoo screen at this moment. Just going to open the chat box. It's open. Okay. First things first, if you start up your inverter, the first settings that you'll have to do is your battery settings. That's setting number 3. Keep in your enter button until you hear the beep change. Then you go to setting 3, and that's where you select the type of battery that you'll be using on this inverter. So for instance, I have a lithium battery here that I just didn't communicate at this moment. So I put it on lead acid settings so that I can run it on user-defined voltage settings. But you can decide if you want to use lithium or lead acid or no battery at all. So we leave it on lead acid battery. Then you see the box flashing with 100 in it. That is the ampage of your batteries. So if you have 100, 200 or 300 amp hour battery, you just tell the inverter, listen here, I have this size of battery that's on it at the moment. So that's basically it. And then you press enter. And as soon as you press enter, you'll see your machine will switch on and off. So when it go on and off, you'll see on the battery information here, you have to see a value there before you know the machine accepts your battery. If you have a lithium battery and it does not communicate, it won't show any value in this box. Now, from the battery settings on, the next important settings is setting number 21. Setting number 21 is where you are able to tell the machine the parallel mode. So as I select setting 21, you'll see on the top hand corner, there's a 1 pH flashing. That tells the system it's a 1-phase parallel system. As soon as you press the up button, you'll see a number flashing for 3 PA. That tells you it's a 3-phase parallel system. So on a 3-phase parallel system, you press the enter button, then you can select the composed phase for this one, phase 1, 2, or 3, and then you just press enter. For I'm here having a 1-phase system, so I'm on 1 phase. I press enter, then P1 will flash. It's the first phase. You can't change the phase of a 1-phase system, so it's going to be 1 phase. And then from there on, you press your enter button, and then you'll see a battery shared enable option is flashing on the screen. So the top right-hand corner, the flashing number there is battery shared enable. So this is for when you have a parallel system that both inverters is using the same battery, so that the master inverter can relay the information of the battery to all your slave inverters. This is especially important for a system with a lithium battery that's communicating with the inverter. I see I have a question here. Let's quickly answer the question before we go on. If you have a 200 amp hour and 2 inverters, do you set each inverter as 200 amp hours or 100 each? You'll see you only have to do the battery settings on the master inverter, then it will relay the settings to the slave inverter. So it's not necessary. You put in the master inverter as a 200 amp hour battery system, and then it will be fine. So you don't have to put 100, 100. It's a 200 amp hour bank that the 2 inverters is sharing. So on a battery shared system, you enable it, then the master will relay all the information. And then as soon as you have 2 batteries and one inverter has its own battery and the other one has its own battery, then you go to your disable option. As you see, it's then disabled. Then each inverter knows the information that it received from the battery is its own battery. But as I have a battery that's shared between my 2 units, I'm going to press enter. And as soon as I press the enter button, you guys will see the inverter will restart, and it will go through the whole setup process of starting up and giving out power. So let's just quickly wait for everything to go normal here. Okay. So on this system, everything is happy and normal at this moment. Now from here on, both inverters is connected with internet cables. I'm quickly just going to change my camera angle so that I can go through all the wiring work with all of you. Just give me a second here. Okay. On this inverter, this is my second inverter at the moment. You see, it's also running and happy. It's a single phase parallel system, this one. So from here on, you'll see that we have our input line and our output line. And our input line and output line is shared between the two inverters. And then as well as a battery connection from the one inverter and then a battery connection from the other inverter. So you must see these two inverters as its own installation, if I can put it like this. This inverter has its own input and output breakers. I'll go through that box as well with you guys, and its own input of the battery. It's not necessary to have all of them PV, but it's advised to put the same amount of panels on the one inverter and on the other inverter. So both inverters work on the same load. Okay, let's make it like this easier. Now for my parallel box. I see you have a question here. I see you asked inverters don't take more than 250 amps. I'm not sure what's the maximum amps on the lead acid one. I've never tested to see this. We can see what's this one. Yeah, I see it's 250 amps is the maximum that you can tell it's there. But yeah, the amps just give the inverter a workaround for the SOC. It just works off that value to generate a guest SOC if you work on a non-communicating battery. Okay, on my parallel box, you'll see I have my two input breakers. Then I have my changeover switch and then an earth leakage to provide power to the loads. Then I have an SPD and my two input breakers. Now from this box, I like to do my paralleling work underneath my changeover switch because it has nice big holes to clamp all the wires nice and safely into it, as I have done here. My input of my output breaker of my first inverter joins there. Then I have my output of my second inverter joins there on my live side. Then my neutral side is joined there and my neutral side is joined there. So this is where my two join of the two inverters takes place, where the paralleling happens. I have clients that done this paralleling before the output breakers. That beats the reason why I have output breakers. The reason why you have output breakers is to disconnect a system. If one inverter breaks and something happens, you can only switch one off, and then you can also switch off the input breaker, and this inverter is completely isolated from the rest of your system, and you can only go back to adjust the settings for the amount of inverters that you have left. So for this system with the two inverters, my output breakers are combined at the bottom of my changeover switch. This is where the paralleling happens. Then the AC connection, you'll see I pull the AC connection also at the bottom of my changeover switch. From Eskom comes in here and there, and that's where I pull my live and my neutral. Then it runs all the way to the top of this side. Now on my SPD, I bring in my power and it jumps over from the SPD to the first one and from the first one to that one. So both inverters has the same input power from my live and my neutral on the top of my breakers. And from the bottom of the breakers, it goes to each inverter on the input side and the input side on this one as well. So that's basically the wiring work, how to wire a parallel system. Does anyone have a question on the physical electrical wire work before I go to the communication cables between the two inverters on a parallel system? Any questions there? Okay, I'm just going to move on to the communication part. On the communication, you'll see we have a communication cable on the first port that runs all the way to the inverter's last port. So for this inverter, we only have two. So it's the first one to the last one. And on this inverter, it's the middle one. So it's the first one that runs to the second one of this inverter. So you basically have a loop system from first to the last and the second to the second inverter. That's how you do the communication. If you have three inverters, it will be exactly the same. The first inverter is this one, runs to your third inverter's last one. So this cable is between the first and the last inverter in your communication chain. So it depends on what amount of inverters you have in this parallel system. Then very important, at the bottom of the inverter, you'll see there is a red box with two dip switches. Your first inverter and your last inverter, both dip switches must be on. As soon as you have a system with 2, 3, or 4 inverters, it stays exactly the same. Your first inverter and your last inverter, dip switches must be on. And the rest in the middle will be off. So your middle connections between the inverters is the first one, both dip switches on, the second one off, third one off, fourth one on. If you have a system of 3 or 4 or 5 inverters. If you only have 2 inverters, it is 1 and 2. This small dip switch tells my inverters where is the position of which inverter. So the inverters only want to know about which is my first and my last inverter in the communication chain, and from there on they will be happy. The earth bonding, I'll quickly speak to you guys about now afterwards this one. Is there any questions that one have about this system at this moment? I'll get to the earth bonding in a minute. That's a whole topic on its own. I'll get to that one now. Is there any question on how to wire this system further? And then at the bottom, at the beginning, I also said about the settings of the number 21 for the parallel settings. Always remember you have to do it on all your inverters. You have to go physically on all of their screens to say setting 21 is a one-phase system or a three-phase system to give this inverter the right position in the parallel system. So you give it a one-phase parallel system or a three-phase parallel system. So you have to assign all the inverters to a parallel setting. So you can't just do the first one, and then the rest of them will accept the setting. You have to go to each inverter and physically do the settings on it. Okay. Let me just quickly have a look here on the questions. Please, can we get the recording training? Okay, yes, that will definitely be on YouTube. We'll definitely load this video on there for you guys. Okay, then I see the only other question is the earth neutral bonding. So the earth neutral bonding is something that you still have to do. I'm just quickly gonna put down this video now. So earth neutral bonding is something that you'll have to do yourself. The inverters doesn't do it manually. We recommend that you put in a normally closed contactor on your DV board that is connected to Eskom power on the A1 and A2 side of your contactor. That's your coil side. So when Eskom is on, the coil is pulling open your connection. That means that your neutral and earth will not be bonded. Then you can take a wire from your neutral and a wire to your earth on the contact on the other side. So as soon as Eskom fails and it's load shedding, then the contactor will close by itself because it's a normally closed contactor, and then your neutral and earth will be bonded when there's no Eskom. As soon as Eskom comes back, then your neutral and earth bond that you've created will be disturbed and it will open. as soon as the coil gets power, and then the neutral earth bonding will be done on Eskom side still. So at this moment, it's still necessary to do your own neutral earth bonding. Otherwise, your earth leakages and stuff like that won't function correctly. So that's the thing on the earth neutral bonding. Is there any other question or something that I didn't answer on the neutral earth bonding that you'd like me to answer maybe?
Hello.
Yes.
What should be the minimum maximum voltage input for ideal condition? In any worse condition, like in case of double phase of input side, what may be happened?
So what you want me to answer is, what is the minimum and maximum voltage input for the inverter?
Right.
Okay. Now from this inverters, it's difficult to give you the minimum. In the settings, there is if you go to the settings parameters, there is settings that you can change for the minimum and maximum input on it. Usually your maximum is around 250, just above 250, then the inverter won't accept Eskom, and the minimum usually is around here by 180, around there. So it's very difficult to give you a precise answer on what is the minimum and maximum that we accept on this inverters. I'll ask my R&D team to give a spreadsheet on exactly the amount of your maximum and your minimum voltage that will be accepted from Eskom. But as I have it, I think it's a 180 and then up to 250 around there. But it's all parameters that can be set on the inverter itself. So we have the ability to change the parameters. I know, like in Joburg, there's certain areas that has their voltage 250 plus almost constantly. We had a case of this, and then the R&D team of Luxpower went into the inverter through the internet dongle, the monitoring app, and they have changed the settings so that the inverter will accept the Eskom power at that high level. So we have the abilities to change it if we need to change it, but usually it will be around 180 to 250 is the range it will accept the Eskom, but it won't give out 180 to your house loads. It will always give you 230 or the amount that you told the inverter the output side must be. It will keep it at that level. So it won't run higher power to the house or to lower power. So it won't give you 180 volts to your load.
Okay. And second thing, what happened if in any case input voltage beyond limit, like 300 volt or 400 volt input side? In some cases in rural areas, there are some issue. Okay. In sometimes there are double phase maybe happened. Okay. So that time voltage will be around 400 volt. So in that case, with the 400, what may be happened with the inverter?
Okay. The inverter will definitely get damaged if you give it 400 volts on the input side. But that's why if you go back to my box on my screen, let's quickly go back to my screen that I have here on Yaku's screen. That's why we recommend you to put in an SPD.
Right.
So we have this SPD. I just want to get this camera to focus here quickly.
Aye.
Okay, I see this camera is just slightly struggling to focus now. But this is a 275 volt SPD, my SPD on the input side. So my SPD will melt and throw all the current that's going through it, through the earth away before it will damage the inverter. So that's why we always recommend you to insert a SPD in your line to protect the inverter. So these two inverters won't get damaged through what you just told me, because I have the right protection devices built into my AC box to protect my inverters.
Thank you.
100%. Is there any other questions that somebody would like to ask about the paralleling system? What can we do? Okay. No, you have to keep your inverters exactly the same. So it will be a 5 kilowatt and a 5 kilowatt. At this moment, we won't have the 3 kilowatt inverter being shipped to South Africa. The costs on the 3 kilowatt inverter and the cost on the 5 kilowatt inverter is very similar. So it's not financial viable to send the 3 kilowatt as well to South Africa because there won't be a big price difference between the two inverters. But to ask your question on that one, no, you have to use exactly the same inverter, a 5 and a 5 kilowatt in a parallel system, and you can't mix my hybrid version, my LXP, with the SNA off-grid eco hybrid. It has to be exactly the same model and exactly the same size inverter, and you can't mix two brands of inverters as well. It has to be a Luxpower SNA 5000 with a Luxpower SNA 5000. And then as well, I forgot to mention this, you can parallel up to 10 of these units. So if you like to build a 50 kilowatt system, then you have the abilities with these inverters to build up to a 50 kilowatt system with these inverters.
Okay.
Is there any other questions that one would like to ask?
How many inverters we can connect in parallel in case of single phase?
You can go up to 10 of them.
Then we can go up to.
Yes, you can go up to 10 inverters in a single phase parallel system.
Okay, and same thing will be happen with the three phase also?
Yes, I believe you can add up to 3 of on a phase to make them a total of 9 inverters in the 3-phase system.
Okay.
Yes, because the thing is, as soon as you have 10 inverters, there's a lot of communication that has to be done between the inverters. So the limit is around 10 in the single phase system is 10, and I believe on a 3-phase system it's 3 per phase. That runs up to 9 of them, if I'm not mistaken, on the 3-phase system, to keep the system communicating and working well. And on a 3-phase system, your wiring work will still be exactly the same as I showed you guys. Your first inverter and your last inverter and the ones in the middle will all be daisy chained. The 3-phase system will be or can be parallel, but we don't have a 3 kilowatt system. We don't have 3 kilowatts that will come to South Africa. So yeah, the 3 kilowatt system won't be sold in South Africa anytime soon. So you won't find 3 kilowatts, unfortunately, to parallel. Except if you have somebody that sends them from overseas to you, then you can try to parallel them. But the 3 kilowatt system I don't work with because we don't get them in South Africa. Only the 5 kilowatt and the 6 kilowatt versions will be available in South Africa. And then we have our 10 and 12 kilowatt units that's been shipped to South Africa. So hopefully in the next month to a month and a half, we'll have our first 10 kilowatt units in South Africa. Yes. Okay. For the LXP, okay. I'll first answer the first question there on the LXP and the SNA 5000. Your two main difference between your two inverters is the SNA 5000, the one that I've done the training on today, is my eco hybrid. It's an off-grid inverter that has the abilities to do some of the hybrid functions, but it's not a hybrid inverter. Where my LXP is a full hybrid version that works just like the diodes with a CT meter to provide load to your non-essentials without feeding power back to the grid. Where the SNA 5000 has the ability to backfeed, but you can't limit its backfeed only to the non-essential side. So if you backfeed all the power that it can backfeed. So if you tell this inverter you may backfeed 50% of the available power, then it will backfeed 50% of the available power. Even if your non-essential load is only taking 30% of that power, the rest of that 20% will go into the grid. With the LXP, it won't go into the grid. The inverter will measure the amount that is needed to provide to your non-essential side. Okay. I've explained the LXP system. If there's any questions on that one, I'll quickly go back to the LXP system. Then I see here's a question. Does it work when two batteries in series? Okay. For the two batteries in series, you mean to have a higher voltage of 48 volts. We have a 6 kilowatt hybrid high voltage system that can go up to 300 or 400 volts on the battery side. So that's our 6 kilowatt high voltage battery system that we also have. That's a fully hybrid inverter as well. But my LXP and my SNA 5000 can only take up to 60 volts maximum on the battery side. That's where the voltage range lies for my SNA and my LXP inverters. Okay, the inverters have everything built into it. The only thing that you are going to have to buy to do a parallel system is 2 straight communication cables, and that's it. The rest of the inverter, everything is in the inverter. The cables are in the cables you have to buy, the 2 straight communication cables, but the parallel board and everything is installed in the inverter. Your monitoring dongle is in the inverter's box. So you're just basically going to have to buy 2 small paralleling cables. That's normal RJ45 straight pin 1 to 8 cables that you're going to buy, and that's it. Okay. Okay. Okay, so I see she also answered you, Meame also answered you there for the paralleling system. Yes, everything is included in the system. You don't have to buy a separate board or anything. It's only the cable. And it's a normal internet RJ45 cable. Okay, see, Meame also answered you there for the question that you've asked on the West Africa. If you have any other questions, they feel free to contact Meow. She'll definitely have the right answers there. She works for Luxpower South in China. She'll definitely answer you on that question. Okay, I see there's another client that would like to join. Let me quickly see. Okay, I believe they have joined. Okay. Let me just quickly go back to the chat here. Okay. Okay, but can the SNA be safely limited completely for zero feed in as when you have prepaid? Yes. The SNA can be set to do no backfeeding at all. So what you're going to have to do in that case is you're going to have to disable the feeding grid function and as well as the hybrid function that this SNA have. As soon as you enable the hybrid function that allows this machine to use PV power and AC power jointly, there is a small amount of backfeeding that occurs. So in this case, you are going to have to disable the hybrid function and the feed-in grid function. Then this unit won't backfeed any amount of power. So then it will safely be set not to backfeed at all. Okay, I see that's for the questions. I just want to see if I missed somebody's question somewhere. Please ask any question that you feel free, even if it's not about the parallel system, just about the inverter specs or anything, you can ask the questions now. It's possible to connect SNA. Okay, I just want to read this question again. I would like to know if it's possible to connect SNA or are they an on-grid plant installed and take the surplus energy from the grid system to charge some batteries. Okay, so as I understand your question, you would like us, if you would like the inverter, like let's say you have a grid tie system that's installed at this moment, and you would like to use this inverters only as a backup type of system, like let's say for an office or a small house that is still connected to this grid tie type of system. Do I understand your question correctly? Okay, I see. Okay. Just quickly on the generator question. No, your generator input has to go to all the inverters in the system. So your master and your slave inverters must have your generator input. You can't only connect it to the master, then it won't accept it, because the parallel system will only function when all the inverters has the same input. That's why it's important to give them the same input on all the inverters as well as the output that's combined, obviously. But on the input side, you have to have all the inverters have to have an AC input or a generator input if you'd like it to work. Now back to the question about the SNAs on the, let's say like a grid tie system. Yes, you can definitely do it. Because a grid tie system only supplies load into the already existing grid. So if you have, let's say 2 or 3 SNA units with batteries somewhere, the power will only come still from your main supply from Eskom that is helped by the grid tie system. So you can definitely do it that way. But I don't know if you can connect, let's say you have a grid tie system and you connect it directly into the SNA. I'm not sure if that will work, but if you have an existing grid system, let's say you have like a complex with a lot of houses that's already fed by a grid tie system into the complex main, just to bring down the electricity bill, then you can definitely add SNA units in the houses to run solely on backup systems. And it will use that Eskom power that's provided from Eskom and the grid tie system combined to power the house when there's no load shedding. Then that will fall away, but it will charge the batteries in that way. If I understand your question correctly. If I don't understand your question correctly, just rephrase it for me, then I'll see to answer it in that way. No, unfortunately, the inverters is very sensitive on the generator input. You don't want your voltage to fluctuate at all your hertz the same. We recommend to have at least a generator matching the size of the inverter or even slightly bigger than the inverter to provide the loads. Meaning for this is a generator, as soon as you pull more than 50% of the cheaper versions capacity, they start to fluctuate a lot with their volts and the hertz to struggle to keep up the voltage and the amps that you are looking to draw from the generator. We had systems that accepts the generator if it's slightly fluctuating, but there is systems that does not want a fluctuation at all. So you try to keep it as close as possible to 50 hertz, and then input voltage from 220 to 240, it will accept it without any problems. But a generator is a difficult thing to get 100% right. Usually our smaller, cheaper generators fluctuate extremely. Some of them goes up to 45, 46 hertz, up to 53, 54 hertz. So some of them fluctuate extremely, and then the inverter won't accept it. I'm not sure on this specific Hubble. I know Hubble is on our compatibility list. So I know Hubble is on our compatibility list. I'm not sure about the AM2. I haven't worked with this specific battery yet, but I can definitely find out to see if the specific battery of Hubble is supported. But I know Hubble is supported on our compatibility list, and it uses protocol 2, the same as PylonTech, to communicate with the inverters. But I will definitely find out if the Hubble AM2 is compatible with the Luxpower, but I believe it should be. But I don't know this battery that well, the Hubble battery. So I'll first have to go find out for you, just to make sure that I give you the right information. I'm just quickly going to type in my cell phone number here, that you can send any other questions to. If you think about something, feel free to WhatsApp me on this number. So then I will get back to you on some of the questions as well.
What will be the maximum charging current, battery charging current? Okay, it will automatically set if we will say, feed a battery age capacity, or we have to set it manually.
Okay. The maximum charging of the inverter will be around 110 amps that you can charge from it. That will be roughly around 5 kilowatts. The charging current, that's 110 amps. If you have a battery that's communicating, then it's no need for you to set this. Then the communication of the BMS and the inverter will adjust the maximum charge. You can't go higher than what the BMS tells the inverter. But as soon as you have a battery that does not communicate, then you'll go down to setting number 6 on the inverter screen itself. There you can set the maximum charge current. So you can tell the inverter only to charge by 30 or 40 amps. And then even if you have a battery that's communicating, I don't like to charge my batteries more than 40 amps on a battery, no matter what size the battery is. I usually put my setting number 6 on 40 amps. And then even if the BMS requests 100 or 80 or whatever type of amps, the inverter will only charge at the amount that you set it on number 6. So if your number 6 is lower than the BMS value, then it will charge at number 6. But otherwise, with a battery that is communicating, it's not necessary to adjust this. It will be manually be done between the inverter and the battery.
Okay. Can we set that charging current if battery is being charged from grid? Okay. Basically, our main concern is to save the electricity bill. So can we limit that battery charging if battery is being charged from the grid supply, ESCOM supply? Okay. So can we limit that charging?
Yes, you can definitely do that on setting number 14 on your AC charge setting. You can definitely limit the amount. I know with the new software that was updated, the screen settings slightly changed a little bit. So you can definitely change whatever value it must charge from ESCOM. At setting number 6, that's also available to do it on the new update. So I see on the new update, it's going to be on setting number 6 that you'll also be able to change your amount that it will be charged from the grid as well as AC. So AC, you can change it up to, I usually leave my AC on like 20 amps, so that it's a slow amount that charges the battery. So when the sun comes up, the battery isn't fully charged from AC, but yes. If your inverter isn't on the new firmware, then it will be on setting number 14. And as soon as it's on the newest firmware, it will be on setting number 6 that you can put on the maximum amount of charge. And I see you can also put in the AC charge amount on setting number 6. So you can definitely limit that setting.
Okay.
Okay, I see he's asking for a remote monitoring app. Yes, there is. We have a Luxpower View that you can download from the app stores, and the web you can go to Luxpower Login. And from there on, you can log into your account and you can monitor the systems as well as change all your settings on this system. Okay, the list will quickly, I can just send you the list on the chat as well. Okay, see Meow Meow send the list there. So the list is in the chat of the compatibility of the batteries versus the inverters. And then we are busy working. We are trying to see if we can get Freedom 1 batteries as well, compatible with Luxpower. I am busy with Freedom 1 and Luxpower to see if we can get them to get the two batteries compatible, and it looks like we will be able to get the batteries compatible as well, Freedom 1s. So hopefully one of these days we'll add Freedom 1 to our battery compatibility list, but unfortunately at the moment it's not. But we'll definitely, we are working on the battery brand Freedom 1 to get it compatible with Lux Powers as well. Okay.
Hello.
Yes.
Hello.
Any other questions that you might have?
So what is your battery charging profile? CCCV. What exact charging profile are you using for the tubular battery charging?
Excuse me, sorry, you broke up there. What did you ask?
Basically, I want to confirm what is your charging profile, battery charging profile, constant current mode, after then constant voltage mode. Do you have an equalized mode?
Oh, okay. I understand what you're meaning. Yes. Okay. Our equalization mode is not active on this inverters. So at this moment, we only have the options for your bulk charging or your absorption charge, your float, and your cutoff. That three settings is the only settings that you can do at the moment for your charging profile. You'll see there is an option for equalization charging that's used on your lead acid batteries, but we don't have that option that's active at the moment. So that option is not active on the inverter at present. I'm not sure if they're going to add this option to activate it, because we have a lot of clients that doesn't like this option, especially if you have a lithium battery that's set to use a defined mode and you forget to deactivate your equalization period and you charge it at 58 or whatever volts, then you blow up your lithium battery. So that's why it's not activated at this moment.
Okay. Okay.
Is there something else that you'd like to know about that charging that I did not answer correctly for you?
Yeah, it's okay. Thank you.
Okay. Otherwise, you can just, as I said, I send my number as well here. If there's anything that I didn't answer clearly for you, feel free to send me a WhatsApp. And if I don't know the answer completely, I'll definitely send the question through the R&D team in Luxpower, and the engineers will give me a much more detailed answer. If you would like a more detailed answer about any question that I've answered, just send it on WhatsApp and I'll get one of the engineers to answer you much more in detail.
Okay, thank you.
Okay. Yes, the training will be fully recorded, so you'll be able to have a view at it as soon as it's uploaded to Lux Power Tech on YouTube. So if you go to Lux Power Tech, you'll see the previous training videos as well as this one of today will be uploaded later today. The Oliter lithium battery. I've had a client also trying to get the Oliter to work. I've never used this Oliter battery before. So it's quite a difficult one to answer. I believe Oliter, as I have it, is not compatible with the Luxpower. I just quickly want to confirm that one before I give you a final answer on that one. Let's quickly have a look here on my. Okay. Yeah, Oliter, I don't see the Oliter battery on my compatibility list. I have a client that also installed the specific Oliter batteries that you are speaking about. But I'll just have a look to see if we can get it to work. on which protocol. If we can get the protocol from the manufacturer, and just if they tell us if they're working on which protocol, your Pylon-Tech protocol, or the same as Dynas, or the above battery bands that we have, then we can see if we can do something for you guys about that. Okay, is there any other question that somebody would like us to try and answer for you? Even if it's not about the paralleling system, feel free to ask any question about the inverter at any point. Is there something about the parallel system that I didn't explain clear enough that somebody would like me to re-advise quickly, to run through that specific part again that you'd like me to quickly run through again before we end this meeting? Okay. Okay, I believe that is that for this meeting. Thank you for visiting us at this meeting. As I said, I'm going to type my number again here. Feel free to WhatsApp me anytime about any questions or something that you might run into on site. Having the big difficulties with setting up and that type of stuff, feel free to WhatsApp me on this number, and I'll get to you as soon as possible to assist you with your problem that you might have on this one. Thank you for joining us, and I hope you have a lovely day. And then I was seeing forward to see you guys at the next training meeting about a next topic. If there's any specific topics that you guys like to hear about in the training meetings, please WhatsApp that to me as well. And then I'll prepare a WhatsApp, or I'll prepare a next training meeting on the topics that I got from you guys. So feel free to WhatsApp me on any topics that you'd like us to do. Enjoy your day. Thank you.
Yeah, thank you, sir, so much. Thank you so much.